Hello and welcome to this video. In this video we will be discussing the recursion technique. Okay, so let's start the video. What is recursion? Recursion is a technique by which a function makes one or more calls to itself during execution, or by which a data structure relies upon smaller instances of this very same type of structure in its representation. In simple terms, the process of recursion involves solving a problem by turning it into smaller varieties of itself. In recursion, a function or method has the ability to call itself to solve the problem. So basically, if we have something and we are repeatedly using that, okay, in our algorithm or while running our code, then that will be a case of recursion. Okay. So these are some examples of recursion. Like we can see that when the same picture is repeated, like we go into the picture and we end up in the same place, right? So these are some examples of recursion. Even the doll thing, this Russian doll thing, where like we have like a big doll is there, inside that there's a smaller one of the same, like it is completely identical to the bigger one, and again inside that there is another small one which is identical. So that is a case of recursion. Recursion in computing. In computing, recursion provides an elegant and powerful alternative for performing repetitive tasks. Recursion is an important topic in the study of data structures and algorithms. Some examples. Binary search is a recursive algorithm. The high-level approach is that we examine the middle element of the list. The value of the middle element determines whether to terminate the algorithm if you found a key, or recursively search the left half of the list, or recursively search the right half of the list. The file system for a computer has a recursive structure in which directories can be nested arbitrarily deeply within other directories. So what this means is, suppose you create a folder and then you go into the folder and create another one. Again you repeat the same process. So this will be a case of recursion. Okay, de factorial function. Mathematically, the factorial function is defined as n, like factorial of n is equal to n multiplied by n minus 1 multiplied by n minus 2, and we keep doing that till we reach the value of 1. Also by definition, the 0 factorial is equal to 1. So now how let us see how we can use recursion in the factorial function. Okay. So first what we do is we define a function called factorial and pass an argument n. Okay, so if the value of n is equal to 0, we are returned the value of 1, otherwise we are returned n multiplied by factorial of n minus 1. So as you can see that we are calling the factorial function again, but the only difference is the value of n is lesser, like it is less by a unit of 1. So this is how we are using recursion technique in the factorial function. So if you try to call the function and pass it a value of 5, so what happens is n is first compared to 0, like equated to 0, and because 5 is not equal to 0, therefore the if statement is passed or ignored, and we are returned 5 multiplied by factorial of 5 minus 1, that is factorial of 4. And again the same step is repeated till we reach till the value of n is equal to 0, where the return is 1. Okay, so this is how we can find the factorial of a number using the recursion technique. Okay, so in the coming videos we'll be discussing more examples using wherein recursion technique is used, and we'll look at binary search and how recursion is used there. And yeah, that is it for this video. I hope you like this video, and subscribe to this channel and hit that bell icon, because I am creating a playlist called data structure and algorithms in Python, so that so whenever I upload a new video you get notified and you're able to follow along, right? So I'll end this video now, and I hope to see you all very soon. Thank you so much for sticking by.